everybody, Miss Mocano here, and I wanted to go over your lab that you're going to be performing soon, your density cubes lab that you can see right in front of you on the screen. Wanted to go through it and give you guys a few hints and just general help on how to go through it. All right, so the lab actually starts with a pre-lab, which is just a little bit of a review on how to calculate volume and a bunch of other things. So the first thing I'm asking you to do is to review calculating volume for cubes. The volume of a cube, I'm showing you an image of a cube right here. And the formula for the volume of a cube, as you can see here, is V equals L to the power 3. We can also call that L cubed. Or it's the same thing as saying V equals L times L times L. All right? Where L is the measurement of one side of the cube, as shown in this picture. So for example, if I wanted to calculate the volume of a cube whose side measures 2 centimeters, simply all I would do is take this formula, V equals L cubed, and I would take V equals, in this case, my side is 2 centimeters, so it's 2 centimeters times 2 centimeters times 2 centimeters, which gives me 8 centimeters cubed. Okay, so I'm asking you basically to do the same thing over here and to calculate your own volume for these 3 different cubes of 3 different measurements. So for the first cube, your side is 3 centimeters, second cube has a side of 1 centimeter, and the third cube has a side equal to 4 centimeters. If you need a calculator to do this, you could simply type calculator, as I am doing right here, and select scientific. And here's my calculator. So let's do the one that I, the 2 centimeter cube. So I can do 2 times 2 times 2 equals 8. Or you can just do 2 to the power 3. So 2, and you use this little symbol for the power to the power 3, which is also called 2 cubed, equals 8. Same result. All right? So feel free to use that calculator if you need it. Moving on to the volume of a cylinder. So you're going to deal with cubes and cylinders in this lab. Here's what a cylinder looks like. All right? For a cylinder, the formula is a little bit more complicated. I am giving it to you right here. V equals pi d squared times h divided by 4. What does that all mean? Well, d is the diameter of the cylinder. H is the height of the cylinder. All right? Pi is just the constant pi, which is usually approximated as 3.14. So let's do an example of that. Let's say we have a cylinder whose diameter measures 2 centimeters and the height measures 3 centimeters. In order to calculate the volume of that, you would use the formula that I gave you. So the volume equals pi d squared times h divided by 4. So in this case, pi is our constant, 3.14. Just replacing the values in here. D is 2 centimeters, so I'm going to replace that, and I can't forget to square it. And h is 3 centimeters given to me, so I'm going to replace that in the formula. Now, putting all of this in my calculator, I can do 3.14 times 2 squared is 4, which is 2 times 2, times, let's see, so times another 3, and then divided by 4. And so I end up with 9.42 centimeters cubed. All right? For practice, I'm asking you guys to do basically the same thing, but for different measurements. Okay, so I'm giving you cylinders with a diameter of 1 and a height of 4. I'm asking you to calculate the volume right here. Your second cylinder diameter of 2 centimeters, height of 5 centimeters, calculate the volume, and so on. All right, moving on to the next skill that I need you guys to be able to master in order, for the test and for moving forward in science. We need to know how to calculate density, mass, and volume using this formula. So this is the formula for density. And what this formula is telling us is that density equals mass, M for mass, divided by volume, V for volume. Okay? So let's do a couple of examples using this formula, see how it works. So for example, calculate the density of an object whose mass, and let me change that to capital M so it kind of goes with our formula, whose mass is equal to 40 grams and volume equals 20 centimeters cubed. So I'm going to write down what the problem is giving me. The problem is giving me M for mass, 40 grams, V for volume. It's telling me that that is 20 centimeters cubed. And it's asking me to calculate the density of this object. Well, I'm just going to use my formula, mass divided by volume. So density, instead of mass, I'm going to put 40 grams because that's what it is. Instead of volume, I'm going to put 20 centimeters cubed. When I do that math, 40 divided by 20 equals to 2. And the units end up being grams per centimeter cubed. Or you can say grams divided by centimeter cubed. Same thing. So again, I'm asking you guys to now practice using different values that I'm giving you here for mass, different values for volume. I'm asking you to use the same formula, calculate the density. All right? Now, this formula for density can be rearranged just using simple algebra. So we can take this formula and rewrite it as, if we know the density and the mass, we can find the volume from this formula by just simply dividing mass by density. And if we know the volume and the density, we can rearrange the formula to find that mass equals volume times density. Okay? All of these three formulas here are in fact one formula but rearranged. Okay? And depending on what we're trying to find, we're always going to work with these three things: density, mass, and volume. Those are our three variables. Depending on which one we're looking for, we pick the right version of our formula. Okay, so this is just to make it easy for ourselves to find what we're looking for, but really, truly is the same formula. For people who are, maybe don't like working with this kind of formula, there's a little trick, a little work around that with this triangle. All right, so this triangle, M is the mass, again, the density, V is volume. And basically if you're trying to find, let's say mass, the one on top, you just do density times volume. If you're trying to find density, then just cover up density with your finger, cover up this D. And if you cover up this D, all you're left with is M divided by V. M on top, V on the bottom. Let's say I'm trying to find volume. Cover up the V, and it gives me that the volume is going to be equal to mass divided by density. M on top, D on the bottom, which is the same thing that we talked about above. Okay? So it's just a little bit of a kind of like a memory trick to help you guys remember. Okay? So let's now use these formulas to find, let's say that we are given the mass and the density of an object, and we want to find the volume. How would we do that? So we're going to, again, going back to, let's say I want to find the volume. I'm going to cover up this V over here. And if I cover up the V, I'm left with M on top, D on the bottom. So volume equals mass divided by density, which is this formula that I just wrote right here. And so let's say my object has a mass of 40 grams, density of 2 grams per centimeter cubed. Using this formula, I'm going to divide mass of, so that is actually wrong here. I'm going to correct that right now. Mass of 40 divided by 2. I'm going to get 20 centimeters cubed for my volume. Okay, so mass of 40 divided by a density of 2 equals 20 centimeters cubed. Now I'm having you guys do the exact same thing down here. And basically, similarly for mass, I'm giving you, in this next section, I'm giving you the volume and density of a substance. I am asking you to calculate the mass. If we go back to our triangle, if I'm looking for mass, I'm going to cover up this mass, and I'm seeing density and volume next to each other on the bottom, so I'm multiplying them, okay? Or you can just, if you're comfortable with algebra, you can just simply use your equation, your algebraic equation, and it's the same thing, all right? So in this example, I'm giving you an object of volume 20 centimeters cubed, density 2 grams per centimeters cubed, and we're using this formula to calculate that the mass is equal to 20 for volume times 2 for density equals 40 grams. And I'm having you guys practice a bunch of examples on your own right here. So finally, once you are done with all these calculations, these being just refreshing your memory, review, hopefully from stuff that you guys did before. Once we're done with all this, now we're getting into the lab. All right, so for the lab, you're going to be using a few materials that I'm going to give to you. And so let me kind of show you what we're talking about. So you're going to be working with these cubes that, let me see, so they look like this. Each group is going to get a box of these cubes. And these cubes are basically made of different materials, just like it says here. So we got aluminum. For example, here is the aluminum cube. Looks like this. You got steel. Here's an example of the steel cube. Looks like this. You have brass, which looks like this golden color, and then you have copper, which looks like, you know, this brownish copper color, and there is oak as well. Okay, so these are the samples that you're going to be working with. What I'm asking you to do is to measure their mass. So going back to our measurement unit, remember to measure mass, you're going to use your triple beam balance, okay? Now measure the mass of these cubes, of each one of these cubes in grams. You're going to record the mass in this column for each cube. Then you're going to go and measure the side of each cube just using a plain old ruler. Please be careful which side of the ruler. There's a metric side, there's an imperial side. In this course, we don't use the imperial units, we use metric units. So make sure you measure in centimeters as it's telling you right here in the table. So you're going to measure the side, meaning one side of this cube, and you're going to record your measurement right here. Next step, you're going to go ahead and calculate your volume using what we did in the pre-lab, using the skill that you practiced right here, how to calculate the volume of a cube. You're going to use that skill and calculate the volumes of these cubes, okay, from your lab. And finally, you have the mass, you have the volume, you practiced how to calculate density. You're going to use that skill right here to calculate the density for each one of these cubes. There are questions here that you need to answer before moving on, and we have the next part is now asking you to work with these cylinders. So let me show you, we got 4 different cylinders, okay? They're going to look like this. You're going to receive them 1 packet per group. So you're going to have aluminum cylinder is the longest one right here. You're going to have your steel cylinder. You're going to have your nickel cylinder. You're going to have your copper cylinder. You're going to again measure mass. You're going to measure the diameter using your ruler. You're going to measure the height of each cylinder. You're going to calculate volume. You're going to calculate density using the skills from the pre-lab that you practice in the pre-lab. Finally, you are going to complete these questions. The last part of the lab is you're going to figure out the density of an irregular object that looks something like this. It's hard to see, but I will give this to you, and you are going to figure out how to come up with a volume for these, because you're not going to be able to measure it using a ruler. I can tell you that right now. You're going to have to figure out a different way of measuring the volume, and once you have the volume, you have the mass, you can calculate the density. All right, you guys, I hope this was helpful, and I will see you in class.